Vanakkam. Now we are going to solve problem 2.10 from Digital Design by Moris, Mano's 5th edition. The question is, given the Boolean functions f1 and f2, show that the Boolean function e equal to f1 plus f2 contains the sum of the minterms of f1 and f2. The B question is, the Boolean function g is equal to f1, f2 contains only the minterms that are common to f1 and f2. In this problem, the functions are not mentioned, so we write our own expressions. I have taken this f1 as x dash y plus x y dash z and f2 as x y z plus x z dash plus y dash z. Okay. Here it is mentioned that ORing of functions f1 and f2 is used. So that contains the sum of the minterms of f1 and f2. It is noticed that we have to find out the minterms for this functions. So how to find the minterms? For this we can go for either the truth table or using the Boolean laws. F1 function consists of two terms, x dash y and x y dash z. These two, in these two terms, this consists of only two variables and the remaining variable z is missing because this functions consist of three variables x, y, z. So in order to include that variable, then only we can obtain the minterms, isn't it? So we are taking this as z plus z dash because we know that it results in 1. Okay, that's why we don't change the actual expressions. So here it is x dash y into z plus z dash plus x y dash z. So when you apply this distributive law, it becomes x dash y z plus x dash y z dash plus the third term is x y dash z. So if you want to find out the minterm, this complement represents 0 value and the original represents 1 value. So it is 0 1 1. And for x dash y z dash it is 0 1 0. Then for this x y dash z it is 1 0 1. So the minterms are this is 2 and this is 3 and this value is 5. Similarly, we are going to find out the minterms for f2. So here we have actually 3 terms. In this, all the 3 variables are available, but here y is missing, right? So we have to include that, like y plus y dash. Similarly, in this x is missing, so we have to include it as x plus x dash. So here first term is okay already, but the second term now becomes x y z dash by distributive law. Okay, then x y dash z dash. So now we are having extra terms, right? And here this should be written as x y dash z plus this x dash y dash z dash. So now we can find out the value for this. So this is 1 1 1 because all the variables are originals. Here it is x y z dash, and so for this z dash alone we put 0, remaining 1. Okay, so 1 1 0. Then for this it is 1 0 0. Then for this it is 1 0 1. And for this it is 0 0 1. Now we arrange it in ascending order as well as we finding the decimal value for this binary. Okay, so this is 0 0 1 is 1, and then this is 4, and this is 5, this is 6, and this is 7. So we got this min terms for f1 as well as f2. Now we find out the e function. Okay, e is what? f1 plus f2, ORing of this f1 and f2. Then as usual we can include the extra variable which is missing. Okay, so it is z plus z dash. Here all the 3 variables are there, no need to include, but here we need to include y plus y dash. Here we have to include x plus x dash. Then we are applying the distributive laws, right? So it is x dash y z plus x dash y z dash. Then here we get this as x y dash z. This is x y z, and on this case it is x y z dash plus x y dash z dash. Okay, then here we get this as x y dash z, then x dash y dash z. Then we have to remove the redundant terms. That means if we have the same term repeating, then it must be written as a single term now. So if we look into here, what are all repeating? we get this x y dash z, isn't it? Here also it is a y, so we can strike it off. So that for identifying that easily, I have written the binary values for all those things. That means this is 0 1 1, 0 1 0, this is 1 0 1, this is 1 1 1, this is 1 1 0, this is 1 0 0, this is 1 0 1, this is 0 0 1. So this term is repeating. This 101 is coming for 2 times. Other than that, we get the 3, 2, 5, 7, 6, 4 and 1. Okay. So rearranging them in order, in ascending order, we get this as 1, 2, 3, 4, 5, 6, 7. So we get 1, 2, 3, 4, 5, 6, 7 as min term. So if you check it back, that is what are the midterms we have in this. Here it is 2 3 5, here it is 1 4 5 6 7. So if you include both the terms, like 1, then this 2, okay, then this 3 and 4 from here, and 5 is included in both the functions, then 6 is there and 7 is there. Okay, so this is what we got here. The E function, which is the ORing of f1 and f2 function, contains all the minterms of this f1 and f2. Okay, so that is proved. Then what is the second question? The Boolean function g is equal to f1 f2 contains only the minterms that are common to f1 and f2. This means the g is the function that is performing AND operation between f1 and f2. So we have already taken this f1 as x dash y and plus x y dash z, and f2 as x y z plus x z dash plus y dash z. Now we are going to perform this AND operation. Okay, so just we multiply these two, taking dot operation here. Okay, so it is distribution. So how we do this? X dash y multiplied or ANDed with this x y z, isn't it? So we do it, and again this x dash y ANDed with this x z dash. So we get this term, that is x dash y x z dash. This is the second term. Okay. Then again we perform this ANDing. That means x dash y and y dash z, this term, right? Then perform ANDing between these two, right? X y dash z and then x y z. So this term we got x y dash z x y z. Then performing AND. So it is x y dash z then x z dash plus this is x y dash z and then this y dash z. So if you look at this, here we have this x dash x that ANDed, right? So we know that x dash dot x, that results in 0. So this becomes 0. And here if you check it out, here also we have this x dash x. So this becomes 0. And if you look at this, here it is y y dash, so it becomes 0. And here we have this y dash y. Okay, so this also becomes 0. Then here if you check, here we have this z and z dash, so this becomes 0. But when you look at this, here we have repetition of this variable, but we don't have the complement and the original at the same term. Okay, so this, instead of having it as twice y dash y, we can write it as y. Similarly, this z also repeating twice. Okay, so we can put it as z. So it is x y dash z. So we got this as x y dash z. So when you put the binary value for this, it is 1 0 1. So what is its decimal equivalent? It is 5. So it is a min term of 5. So already we know that if you check back here, what are the min terms we have? It is 2 3 5. So this 5 is here common for this f1 and f2. That is only available when you go for this g. G is the ANDing of f1 f2. So we get the min term as 5. Okay, thank you.